Yeah, my name's Doug Hooton. I'm a professor at the University of Toronto in civil engineering, and I've been working in concrete area for over 40 years on supplementary cementitious materials, durability of concrete, and performance specifications. It's a funny story. The professor that I had that taught the materials area was a pretty interesting guy, and sort of piqued my interest and got me moving in that direction. So I started working on Pozzolans as an undergraduate even, because it wasn't standard structural engineering. We'd taken all kinds of structural engineering courses, and that's fine, but it's just a lot of calculations and coming out with numbers. Does it meet the code? Does it not meet the code? And the materials thing and the durability aspects I found really interesting, the material science end of things. It was, I first learned natural pozzolans. Well, I'd worked on fly ash as an undergraduate, trying to beneficiate fly ashes. And my PhD thesis was on slag cement hydration when they were just starting that in Canada. It was actually in North America at the time. And doing the research on the slag, I got involved with reading up on other types of supplementary cementitious materials, and including natural pozzolans. The main uses that as I was looking at historic papers, were control of heat of hydration. The Bureau of Reclamation had used natural pozzolans to control heat of hydration in large dams. They also used it, not necessarily intentionally, to control alkali silica reaction, because when they were using these pozzolans in dams, people were unaware of the alkali silica reaction. But they found out it saved them from a lot of problems with dams where they had a reactive aggregate, but the natural pozzolan prevented that from becoming a problem. Well, the history of concrete fascinated me, and I started working on historical things because I was working on radioactive waste isolation when I worked for the power company in the early 80s. And we were looking for natural analogs of materials with thousands of years of durability. So I started looking at Roman concretes and other ancient society concretes from around the world, and I got hooked up with archaeologists. And we were looking at natural pozzolan. Of course, then you start reading about the various Roman structures that are still in existence after 2,000 years, where they use natural pozzolans especially for water-bearing structures such as aqueducts, or the Pantheon in Rome with the dome structure made with natural pozzolans. The Roman structures, they may have started on a sort of ad hoc basis using these materials, but they actually wrote about them. Vitruvius, who wrote a book, The 7 Books of Architecture, it's been translated in English back then, wrote about how to use pozzolans and what they did and how to combine them in concrete to get more durable concrete. So they understood that it was doing good things for concrete. I was looking at it from the point of view of long-term durability of the calcium silicate hydrates, which is what we were looking for if we're going to use concrete and radioactive waste isolation. That if these materials could last, what environment were they in? How were they formed? How could you recreate those? And were modern cements similar enough that we could use them as analogs? Well, modern cements in combination with supplementary cementitious materials could be made into an analog of what the Romans were doing 2,000 years ago. I'm not aware of any failures with natural pozzolan concrete structures. There have been, I guess, not failures, but durability-related issues with some use of other pozzolans, which I attribute to people's lack of understanding of where appropriate use is. Fly ashes, if they're used in too high a quantity in cold weather and they don't get cured properly, then they're not going to fare as well because they're not going to hydrate sufficiently to be durable in the environment that they're exposed to. But if they do things right, they can be very durable. That same mix could be durable if you treated it differently. So it's a matter of using appropriate mixes for the type of construction and exposure that you're going to be dealing with. I would take it as the problems have occurred because of the expectations of contractors and speed of construction. People want things instantly. Contractors want the concrete to be really workable and then get hard really fast and be strong enough that they can move on with their project the next day. And it's that sort of approach that's caused problems because they don't allow things like natural pozzolans or other pozzolans to react sufficiently to do their good things to concrete. And if they don't cure them right, then they won't do their good things, especially in the surface layers for durability. So the speed of construction, I think, is driving it, because time is money for the contracting industry. And so it's not necessarily the price of the concrete, it's the fact that the construction speed is dominating the cost issues with construction. Okay. Especially in the high-rise market. In Toronto, we have a huge number of high-rises, something like 168 tall buildings going on simultaneously, and speed drives the whole process. I think the big unknown with natural pozzolans gets into quality control, and are they the same today as they will be tomorrow? There needs to be a quality process in place. And the other issue is transportation. That there are a lot of natural pozzolans in the western U.S. and they're in other places, but they're not widespread. And again, like any supplementary cementitious materials, transport governs cost in any local area. So people use what's available in their area. So in some areas you can get good ashes, some areas you can get bad ashes. I think the big concern from the industry will be, can you get consistent, good natural pozzolans to replace that? But natural pozzolans are not one product. There are a huge range of products, with every deposit potentially being different than a deposit somewhere else, different mineralogy, different history. So it's hard to say anything specifically without knowing the pozzolan. So you have to test that pozzolan. And the standards are not meant for internal quality control. They're meant for commerce. And so they don't address necessarily all the things you would have to do as a producer to get consistent quality control of your product and demonstrate that to the customer. Because I think concrete industry can use a lot of different materials, but they've got to be consistent. That's the number one issue with, they have to be in sufficient supply and be consistent in quality. And then they can use them. Oh yeah, I mean, the sea ashes especially cover a huge range of properties. Some of them can be very good for things like alkali silica control and sulfate attack. Other ones can make it worse. And so that's one of the issues we're trying to deal with at the standards committees, but then it's hard to get agreement on how to do that. The F ashes, although they don't have that problem, they have a big variation in their reactivity in terms of strength development. So in terms of what would be an optimum amount to use of a certain ash at a concrete plant. And so they're not all the same.